I wonder what made you come over to this talk, whether it's clean code or whether it's reverse engineering. Probably the talk will be about none of those, like in a very pure sense of it. So let me get started. What we will be talking about is yes, reverse engineering, obviously, which is the process of extracting some knowledge or design information for anything made man, blah blah blah. And we'll be talking about clean code, which is a kind of a code that reads as close to human language as possible. And this won't be as academic, other nonsense, because it is very boring. What I'll tell you, and I will start with, is I'll tell you a story. I'll tell you a story about a very bad code. So, how many of you are Java developers? Great. How many of you do JSP still, or did JSP at some point? Yes. I did it as well, and it looked pretty much like this. Yes, it was, oh no. That was a HR system, like 700,000 lines of code, only 20 classes, mostly JSP, pretty much like this. Yes, it was bad. It was very bad. So when I had to approach this code and do something with it, change it, we had to find as a team a way to deal with it. So we've come across obviously two books. The first one, Clean Code. Who has heard about Clean Code as a book and read it? Okay. The other is, that will be funny part, it's implementation patterns. This is Polish translation, which should be readable for most of us, because to my surprise, I'm coming from Poland, I get to know Serbian pretty well. I can communicate. Yesterday I bought a ticket for the bus in Polish. That was fun. So who had read Kent-Beck implementation patterns or come across it? Okay, some of you. Most of you read this book, so we are sorted. I don't need to talk anymore. So let's recap Clean Code. That's the boring part. But in one sentence, for me, Clean Code is really about a situation or avoiding a situation like this. When at one point we are solving a problem and we think that we'll do something with it, like put some comments or put any other buzzword like be more solid, be more dry, or grasp or whatever, and we said, nah, not this time. And then after 6 weeks, we pretty much don't have no idea what's in this code whatsoever. Yeah, we've probably all been there. But I will not be talking about the principles of clean code, because that's something you can get easily from the book or from any talk of Uncle Bob or whoever. What I'll try is to take the clean code from slightly different perspective. Like, do not look at the principles and show it into the code, but just try to find why the principles are stated in the way they are stated. You know, what was the reason for the principle? And that's the reverse engineering, let's say, to a certain extent. So a few words about me. I'm Jakub Marchwicki. I'm coming from Gdańsk, from Poland. That's a not very long travel, but quite enjoyable. And I enjoy Belgrade very, very much. I'm a coder, trainer, a speaker for the past few years. Now doing more freelance independent stuff, which is quite fun. And what I love to do is I like cross the borders of IT world, and that's pretty much what we'll be doing today. And yes, I did user experience in the past. It wasn't user experience as we know it today. It was more of a user experience of a voice system. If you've ever called your bank and they wanted you to press the buttons on the phone to get through some menu, yes, I've been designing this at some point. Sorry for that. So kittens move away. Some agenda. What we will be looking in, what we'll be doing is we'll be looking at certain problems, certain examples, code examples, in a more OODA loop style. So we'll observe certain elements. We'll try orient ourselves. What's the problem there? We'll decide how we can fix it, and then we'll fix it. Get to the better situation. So example 1. Imagine a code. Very, very bad abstraction of a SQL. So we have a class called SQL that's supposed to do inserting, selecting, updating, and few other things. If we look at this code, we definitely see certain problems about it. From my perspective, first problem is this code isn't single responsible. Yes, it is doing SQL, but it's kind of doing, in my sense, too much. It requires modification if you would like to add, for example, yet another update statement. So for me, that's kind of no-go. What I would like to do is to have it separated into several concepts, because SQL as a concept is very broad. And what I would like to have is I'd like to have a separate inserting, selecting, updating, and different queries done in a different abstractions. So what I'll do is I'll create myself a SQL abstract SQL class, which will be responsible for generating the SQL part. And then I'll have a create SQL and select SQL and insert SQL class, like a strategy pattern from Gang of 4 design patterns book. And now I think I can orient with myself with this code, because if we come here and somebody asks us, yeah, just please add update method, what we'll do is we'll probably add one more method. We have no idea whatsoever what are the implications and what else we're gonna break, because it's a big class. It will probably have like more or less a few thousand lines of code. And then we'll probably run away or ask somebody else to commit it, because then git blame or svn blame will show him, not us, which is also always a good pattern. And if we have this one, kind of naturally, what I'll do is I'll create another class, which will be public class update SQL, which will do the update statement generation, and I will not touch anything else around it. You might ask, because I said that there will be a little bit of psychology or reverse engineering, like what the hell does it, combine with psychology, or the reverse engineering, the social or psychological processes. In psychology, there is a term called affordance. Affordance is a quality of an object, a physical object, which allows an individual to perform an action. For example, a node affords twisting, perhaps pushing, while code affords pulling. Like this little clicker affords holding it because it's built in such a way that it's naturally to grasp it in such a way. That's kind of an affordance. Affordance relates to physical objects. Like this one. If you have a door and on one hand side you have a knob, you know to pull it, and if you, on the other hand, you have a plate, kind of, plate, and then you can push it. That's how physical objects around are built, and that's what many designers do when they are thinking about designing new physical things. Something as simple as a box, which looked as a box, but now it's kind of weirdly, it's a box on my screen at least, a regular box. So if you see the box, you know that you can hold it, you can lift it, you can open it, you can put something inside, you can shake it to hear whether there is something inside. It has certain affordances, and it has certain physical qualities that shows us what we can do with this physical object. Affordances are everywhere. They are sometimes done wrongly, like the Jedi doors, that the sign says pull, but there's nothing to pull. And the affordances are also in virtual objects. If you are happy, iPhone, Android user, at some point, this is I think Samsung screen. In the settings menu, you had an option called shortcuts. It had a slider, which kind of signifies that you can turn the shortcuts off and on again, right? That's kind of what this button affords. However, in reality, that's not like this, because you can actually push the whole line and another menu opens. So completely confusing behavior of a virtual thing. Now we can ask me or think, what's the relation to code? Let me show it. So if we have those two abstractions written, the first one affords totally different behavior from a developer. If that's the code you have in your repository and you want to add yet another feature to this abstraction, you simply add a method, and that's probably the first thing you are thinking about. But on the other hand, if what you find in your repository, the initial abstraction, is built in such a way, then inserting a SQL or updating a SQL, it's naturally driven. It drives us naturally towards adding yet another class. We do update SQL, and that's how we probably try to solve this problem. The thing is that each and every code signifies something to other developers, signifies a certain approach, how we would like to add another functions, or some actions that we are allowed or we are driven towards when we would like to do something with the code. The actions, those signifiers suggests like what should be the next steps. And no matter whether it's a physical thing or whether it's a virtual thing, like a piece of code, it's still a thing that affords some other qualities. And what we should, from our like developer's perspective, remember that whatever we are writing down in code, somebody else will be reading it, and somebody else will think, yeah, I'll have to do something about it. I'll have to change it. I have to upgrade it, add yet another feature, and I'll do it in a way that the code suggests. I will do it in a way that has already been there, and I'll just tune it a little bit, because instinctively our brain is going towards the easiest path. If we have to go from point A to point B, our brain goes, oh yeah, the simplest way. So if we see this code, the simplest way is adding a function. If we see this code, the simplest way is adding yet another class. Yes, another class to the strategy pattern. So a thing to take away, like beware of a cargo cult. There is this thing in our industry, the cargo cult, that people will do things in a way because they have always done it that way. They don't try to think why at some point after some time. They'll just take the steps that are already there. If you have ever done Java 2EE or Java EE, you probably know what I'm talking about. If you ever had a Maven build project, which had like 7 or 8 sub-modules for no specific reason, but that has been the corporate standard, that's the cargo code I'm talking about. So whatever we start with, that will be probably lasting forever or for future years, and we should be aware of it. It's not matter whether it's good or bad. People just tend to follow the same steps that we already done. The thing is, I've shown 2 very simple examples, like a monolithic block of code and split it into a few classes. The question is how we can work with those 2, and how we can split together, and how we can effectively walk from one to another and change from one to another, or what we should be thinking about if we start building those different blocks of code. So how we can split the monolithic code base into something smaller, into smaller workable pieces, or how we can organize the classes to be smaller, like upfront. It itself, in my opinion, deserves a separate talk on class design and refactoring, and an hour will be too little. It's kind of a workshop probably, but I'll give you a class design one-on-one, a very small introduction. If I work probably as an engineer or an external or just a developer on a project, whenever I have to do something, my kind of reasoning, my pattern for working with this is like, okay, I have 2 classes of classes. I'm building something new, and I'm working with existing code. 90% of time I'm working with the existing code, but that's my sad reality. I quite enjoy it, and I like it, and I value it more than greenfield projects, but kind of everybody has a hobby. So a new class. How we can structure the class code, how we can organize codes into classes, and how much you can put into a single class. That's kind of an upfront investment when you think how you should be designing it. On the other hand, if you have existing code, you have a question which pretty much in essence are exactly the same, but they are stated differently. So does this class hold too much? Or How can I split it into smaller chunks? And finally, how to understand in a big class what part belongs where. Because we have big systems, we have single class, which has like 6,000 lines of code. We definitely feel that it's doing too much. So different parts probably belong to different places. So where should we start with? Whenever you read or listen to class design think, the first thing you listen to probably is cohesion. Classes should be cohesive. That's what they say. So what is cohesion? Anybody? And volunteers? Yeah, this is a very tricky term, probably. Lots of us kind of feels what it means for a system to be highly cohesive. We know, oh, it's highly cohesive and loosely coupled. That's kind of our mantra. But if you have to define it, that's more problematic. Cohesion comes from Tom DeMarco, a book from 90s. Structured Analysis and System Specification. On a kind of a side note, the best books about IT came over in 90s and 2000s, the best papers. Now we figure it out that they are already there and we rediscovered them. I pretty much like it. Most of the books I buy at the moment are from 90s, which is kind of great lecture. The code snippets are sometimes weird because it's small talk, for example, but altogether the concepts are great. So Tom DeMarco wrote that cohesion is a measure of strength of association of elements inside a module. Blah, 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 blah. No. Not much. But then if you look further, there is another guy called Glenn Vandenberg who wrote that things are cohesive when they naturally stick to each other, because they are like-kind, or because they fit so well together in a mutual relationship. The pieces seem to be related, they seem to belong together, and it would feel somehow unnatural to pull them apart. That's a much better definition, in my opinion, though there are some terms like naturally stable, like-kind, or feel somehow unnatural that makes this definition a little bit fuzzy. So, yeah, because we can duct tape two things together and they stick together. Well, that's not somehow not unnatural, but they still stick together. So, to define whether things are cohesive, I think we need some tools, some kind of mental framework that will help us make this decision. Do those things work together or not? So, how to organize the system? That's kind of, we are about to design something new, whether it's on a big scale like a system or a small scale, a small feature of multiple classes. Is there anything we can do that can help us make the decisions? Has anybody of you came across domain-driven design? Yeah, a few people. This is classic book like Eric Evans, Domain-Driven Design. I don't recommend it because it's a great book, but it's very hard to read. And you should read it kind of backwards. Start in the middle, read about patterns, and start at the beginning. There are two better, like Implementing DDD or DDD Distilled by Vernon Bonn. That's much better introduction. It tells you a lot, how you should organize your system in the building blocks. It introduces patterns around building blocks, like this thing should be stick together in an aggregate. This doesn't really belong, so you can separate it into separate aggregators, for example, or separate context, and then communication between the context and what to share and how to share, and so on and so forth. Very good introduction to how to organize things, especially if you're starting up front. There are obviously lots of articles how to use domain-driven design to work with legacy code, but from my own experience, it's better to start with the greenfield as it's easier to grasp the concepts. But that's kind of a bright side of the story. We are starting something new and we have to work it through together. But if we have legacy code, if this pretty much is everything we have in our systems, how we can distill different concepts into a different class and try to refactor it. And what is a concept and what is too many, and how we can measure it, whether there are too many concepts in a single class. Well, we can start kind of manually and naturally, that if we take even our IDE, that's not very, not bestly shown, but found usages, which has every IDE, whether it's Eclipse or IntelliJ, we can find actually what are the classes are using our class that is at the moment having like 8,000 lines of code, and we don't know where it should belong to. If we organize it just by packages, we see that it's kind of split it into different different areas of the system. That might be a good approach to start splitting it into smaller parts, because it's always easier to work with 1,000 lines of code than 8,000 lines of code. I'll tell you why a little bit earlier. But doing it manually is very time-consuming and not very fun. We can try to measure it automatically. There is something called Michael Further's quadrant, where Michael Further's introduced a way to distill classes that are natural for refactoring. And he said, if there is a complexity of a class, measured in any way you define. You say it's complex because it's very big, or you say it's complex because it has cyclomatic complexity very hard, whatever measure on one side. And then you take churn, so how often does this class change? So, and if the class ends up in here, in this quadrant, somewhere over here, it means that this is a very complex class we are non-stop changing. And that's something, applicable for refactoring. Those are safe points. Those are dangerous points. But then we can take any other measure over here. It doesn't have to be complexity. It can be object references. We can take a class and see how many different objects are referencing, are importing in their code this particular class. And we'll have pretty much a similar graph. We'll have a class that has lots of dependency, or that lots of other classes depend on, and we are changing it very, very, very often. That's a dangerous point in our application. And we can look further there and try to figure it out. Then it will show us what classes we should be looking firstly to refactor, and then we can split it into smaller parts simply by encapsulating different pieces belonging to different parts of the system. And then we'll figure it out that what look on some enterprise architecture presentations as a very layered architecture, in fact, isn't very layered at all. This is something that allows us to pick up the code, the class that we should start with. Then how we are going to start, yes, again, back to the domain-driven design, how we can split it into parts. We can separate into different areas, different contexts in our application. There is a lot about it in Michael Further's books, Working Effectively with Legacy Code. And there's a lot of patterns how you can approach your legacy code and what you can do about it. Michael Further is the guy who pretty much built his whole career about working effectively with legacy code, and I really recommend it, because in most of the times we are not building anything new. We are pretty much working with what already exists. So another takeaway before I jump to yet another example. In my opinion, there is no such thing as legacy code. If no one uses it, you can abandon. You can just walk away, leave it, and no one will care. If you can't do it, it's probably business as usual, and we have to cope with it. We can cope with it either figuring out how to change it, or cope with it by changing not the code, but the way we work or where we work. That's two different approaches. The choice is yours. Okay, so second example, getting more into why certain design decisions are made in the way they are made. Second example. There's a class in Java called observable. It's an implementation of observable pattern, as you might have guessed. It has three different methods, which is count observers, which gives you a number of the observers that are registered for this observable class. We can delete a single observer, so delete a single class from the list, or we can delete all observers, so clear everything. Very easy. But if you think about it, that's kind of working with a collection, because whenever we register an observer, It's added towards a collection and yet another, and we can count them, and delete all of them. So if it's a collection, let's look at the collections API. In the collections API, we have pretty much the same behavior, but if you would like to know the size of the collection, so the count elements on the collections, we have a method called size. If we would like to remove one object, we have a method called remove, or remove all. So if we compare those two one by one, on one hand we have observable, and on the other hand we have collections. And they use a different naming for exactly the same code, for exactly the same behavior. Well, that's not very good, because why it's not very good? We have a different concepts called in this. We have the same concept called in a different ways, which from the coding perspective, through using this API perspective, it's very hard to maintain in our head, because naturally, if we're working a lot with collections, if we have a class called observable, I will naturally go for size to see how many objects are within this collection, but there is no method size. If you look into an API design principles, like for example, one presented by Joshua Bloch, who actually wrote the collections API, you have three fundamentals for proper API design. We should have short, self-explanatory names for our APIs. We should have consistency, so same things should mean exactly the same everywhere in our code base. And last one, we should have kind of limited number of parameters properly ordered. So we've seen those two already broken, because the same concept, like getting the size, removing an object, has a two different meaning in the same core Java SDK. It's probably due to some time, history, but yeah, it's different. It's much different. Why it's a problem? Why this doesn't work so naturally, especially when our API is very broad? There was a guy in 50s. Well, there was a guy, George Miller, who in 50s wrote a paper. The paper were called "Some Limits of Capacity for Processing Information." It was psychology. And he wrote something like this. There is a magical number of 7. He picked up the number, very arbitrary, but it's not about the number. He wrote that the span of immediate memory imposed several limitations of the amount of information that we are already able to receive, process, and remember. By organizing the stimuli input simultaneously into several dimensions or successively into a sequence of chunks, we managed to break, or at least stretch, this informational bottleneck. He wrote that in our immediate memory, we can hold as much or as little as 7 things. Later, through past 40 years, there were different papers saying that it's not 7, it's 5, or it's 9, or it's 11, or just little as 3, or we said, it's not discrete in any way. But there are a few things that never have been, that has never been questioned, like the amount of information and the sequence of chunks, or organizing the information in the several dimensions. That has been never questioned. And if we think about it, that's pretty much exactly what the clean code functions chapter is about. Because the functions chapter say that functions should do one thing and it should do it only. And clean code definitions of a function is because we are eager to structure information and to separate concepts, a very small concept, kind of a bite-sized information, and then exact it to the functions. And it's not that somebody figured it out. No, it's because it has been always there as a way to structuring information. If we look at things very, very ancient, we already see that those small buttons are organized in a certain way, that there are not lots of them, but they are structured in different colors. And this is because we can intuitively grasp that there is just as little as 4 or 5 or 7 elements. This is kind of a limit that we don't have to count. We just look and we know it's 4, we know it's 5. Because it's small, it fits into our head, and that's exactly what functions chapter was about. And then if we look back into the API design principles, we sometimes call them principles of least astonishment, because we don't want to feel anybody astonished by our API. We don't want to feel other people to just think and, damn, what was this function name? How it was called, and then look through everything that our IDE is suggesting us. What we would like to have, would like to have consistent naming across whole application or across whole system, that the same things means the same, exactly the same thing. That means exactly the same concept. This is because our memory is very limited and we don't want to stretch it. We just want to organize things into a similar concepts. So if we look at those two, we see that if, for example, observable follow exactly the same pattern, the naming will be consistent as with the other collections. The names are so short and explanatory, and no, we haven't yet talked about parameters. So let me jump through into yet another example. In the class called string, there is a method called region matches. If you come across it, you've probably seen that there are two overloaded versions of it. One is holding 4 parameters, the other is holding 5. And until I was regularly using it, for whatever reasons, I always struggled with identifying what does Boolean exactly mean and what are the reasons for different parameters over here. That's not natural. On the other hand, also in core Java API in JDK, we have a SQL statement, a class handling SQL operations, and they tackle it slightly differently. They have an execute method, which takes a string, which is a query to be executed. But if it's an update query or an insert or a read query or a write query, they distinguish it through method name. So they have execute query or the execute update. And then ideally, it tells the user what kind of operation is expecting from this particular function. So let's get back to this one. The first Boolean was actually case sensitivity. Yeah. So if you wanted to match the regions, but not case sensitive, you set true as the first parameter. That's not something natural. You have to remember it. You have to learn it, which is bad. You can just write it in the name. You have an explicit explanatory name that those two will be case insensitive. But you can do even better. There is a thing in Java, not only in Java, called builder pattern. Who has come across builder patterns? That's quite popular. And that's exactly why we are using it and why we like it. Because we don't have to force user to remember how to do certain things. We can drive them through the implementation. So region matches explained. The first integer is an offset. Where should we start matching? Then we have a string, which is another string we should match against. And it might also have an offset. And then we should match it on a certain particular length, which is another integer on this function. And now if we compare it one by one, we see that, yeah, the builder is more explicit, it's more boilerplate-ish, let's say. But on the other hand, it doesn't require us to remember any particular API design decisions that has already been made by somebody else. Then people who just wrote this API just drives us through how it should be used and whether this parameter is an optional or we have to use it or we don't have to use it. Why it's working like this? Why do we have to avoid stretching our memory and memorizing certain things? That's another psychology example. Learning is hard, and remembering things is even harder, because in the first example of the region matches, we have to memorize the order of parameters and which parameters are built in what way. And in the second example, it just drove us, it just walked us through the API without requiring any upfront investment from ourselves, like learning how it is built. This is because, and it's driving and it's working like this, because the way our memory is built, it's built out of stores. We have multiple stores in our memory, and they are responsible for different behavior. If you look at it, we can show it on the graph. We have a stimuli, we have some observation, we have something that's external, and the first register in our memory is the sensory memory. If I touch something, there is an information coming to our brain that I've touched it and it has a function. It has feeling like wood, for example. Then if I don't pay attention to it, it's immediately lost. It stands for like few seconds, maybe, usually milliseconds. We can remember lots of things because kind of our senses are constantly discovering everything around it, and if we don't pay attention, we don't even register that we were looking at something. That's usually when you walk with your girlfriend and she says, "Yeah, you were looking at that lady." No, I weren't, because I haven't yet even registered that. That's the sensory memory. But then if we register it, if we start processing it, then it gets to a short-term memory store. So it's second register. This is pretty much what George Miller was writing about. This is a memory, this is a register that can hold a limited number of information, like 7 pieces. So we see something, we said, oh, it's important, and then we put our attention to that, and we see, okay, this function has 7 or 5 parameters, or it's built in such a way. Okay, and then we move to another block of code, and we remember it for a few seconds, that it has 5 parameters, and we should be building it in a way we are building it. That's pretty much how it works with kind of coding with the Java doc, or with the API design instructions that, okay, these are the parameters, I'm coding it. Like this. And the information is either passed on, so we start learning it, or it's lost. So if we look at the Java doc and see, okay, this function has 5 parameters, and we then switch to the IDE and try to code it, and somebody else came over and asked, hey, what you're grabbing for lunch? We said, I have sandwiches, but then we get to the IDE and said, what I was writing about? Oh, yes, Java doc. And we look at it again. Why? Because we haven't rehearsed it, we don't remember it, we haven't yet learned it. And if we start to learn things, it's a repetitive process that it gets back to our long-term memory. And long-term memory is great, because it's pretty much unlimited. We can learn everything and it stays there forever. Obviously, for some people it's easier process, for others it's a harder process. But long-term memory is like an optical disc. We can write a lot of information there. It's there forever. However, the process of writing it is very long. It takes sometimes minutes, it takes sometimes hours, and it takes sometimes 10 repetitions, 20, 40, and so on and so forth. If you've been doing JPA for years, you pretty much know all the annotations by heart at the moment because you've learned it. But if you're starting with it, no, it's not very natural. So let's look again into the code. Having said how our memory works, we see that in the first example, we have to just learn it. We have to learn that the eigenmatches function has 5 parameters. The first one is case sensitivity, it's a boolean, and then we have an offset and another string and an offset and length. You know, if you've been using this function for once, twice, or 10 times, you probably learn it. But if you don't, you can do it better. You can have a builder pattern that will drive other developers how to use your function. Obviously, you can leave this one for kind of, experts, or for people who would like to use it straight away. But for people who are just starting to consume the API, starting to consume your code, this is much more natural. Why? Because they don't have to learn it. They can just walk through the API. IDE will tell them what is the next step, and they will never ever have to get it from the short-term memory to the long-term memory. They will never ever have to rehearse it. And that will make them more efficient, because they will just see what are the next steps and will follow them. Another takeaway. If we talk about user experience, we usually talk about user experience in a sense of somebody sitting in front of the web application and have this red button for console action and green button for the call to action and not too much information and everything we know about user experience. But in my opinion, there is something like user experience for developers. Our fellow developers are users. They are using our code, they're consuming our API, and they also deserve a great user experience. And we can provide them with it. Let's look for the fourth example, that's the last example, and how we can provide user experience and what's the relation. So example 4. We know memory model. We know how much information we can put in our brains. We know where it should be stored, and we know that a function or a class signifies certain actions, how we can work with it, how we can change it, and how we can work it through. So the kind of API design as a user experience for developers. So let's look more into usability. We have a class. Well, it's a kind of a method. It's a factory method for creating a user. It has 11, if I remember correctly, parameters. Most of them are strings, 3 of them are Boolean. A situation pretty much regular in many code bases, especially, no pun intended, those inherited from far Asia, coming here from Pune. At least that's my experience. Can we do it better? Yeah, of course we can. We can change it not to be some primitive obsessed into classes, so that at least we know that it's a name or it's a salutation, this is a suffix or prefix, and some addresses. Slightly better, but still too many parameters. Now at least we know which parameter means what, which is good. If we try to use this method, it's not very usable, because running this method will pretty much look like this. Name, Jakub, surname, Marchwicki, that's me. The third parameter is null because I don't have a middle name. Then salutation, yes, it's Mr., but I don't have a suffix. You know, there is only one in my family, so now 2, 3, and so on. So another null. Then address is not relevant in this case, so 3 nulls for the street address, city, and state. Yes, I am male. I am employed, let's say, because that's pretty much true for 95 people in this context of this function, and the last parameter is not relevant. Again, very popular situation. So we had lots of nulls, which pretty much we don't know what they mean about. So again, can we do it? Can we do it better? Yes, we can create even more condensed function, or we can start using a builder pattern. For example, we can have a create person that will use a builder pattern and will drive us through implementation. So with a full name, and then we can Jakub and Marchwicki, let's say, and see it already forces mandatory fields. So if you cannot create a full name without first name and second name, it's kind of implied, and then middle name, which is actually optional. And you can say this person is male, which is better than with gender.male. And it's not employed because most of people are employed, so we can bypass this element. So that's one way. Or, as with the example of region matches, we can do some functions overloading. So we can say create male person, or create a generic person, or create a female person, and so on and so forth. Why I'm talking about it and what's the relation with the usability? If we look at any usability checklist or heuristics, one of them is that the data entry screens, the forms on the web page, should contain default values when appropriate and show the structure of data. That's why the primitive obsessions as our classes is so bad, because it doesn't show the structure of data, and it does not provide any default values. So pretty much usability heuristic, usability point from usability checklist is very applicable to our code design. Are there any more of those? Let's walk through some usability heuristics, the basic ones coming from Nielsen. So there was a guy called Jakub Nielsen. He was Danish, actually. And he wrote 10 general principles of usability. He called them heuristics because they were a kind of rule of thumb. It was something to evaluate the systems. There were 10 of them, and some of them are very applicable to our code design. The first one, visibility of the system status. The system should always keep users informed what is going on through appropriate feedback within reasonable time. Imagine these are heuristics for a web page that is behaving in certain element, and we just click the form and nothing happens. So he said, yeah, we should inform users. Does it relate much to coding? Not much, in my opinion. But there are more of those. Systems and the real world much. The system around us should speak the user's language with words, phrases, concepts similar to the user's rather than system-oriented terms. Follow real-world conventions, making information appear in natural and logical order. Yeah, that's quite important. You remember the Regen matches functions? We could have talked to the user with a very internal, low-level dictionary, integer, boolean, integer, integer, or we can talk with the user or the fellow developer with a more natural flow of actually explaining what each parameters mean. User control and freedom. Users often choose system functions by mistake or will need a clear mark emergency exit to leave. Well, yes, it's important, but it's programming. It's kind of for granted. We always do it, and every IDE allows us to walk away path we shouldn't have entered. Consistency and standards. Users should not have to wonder whether different words, situations, or actions mean the same thing. Follow the platform conventions. That was written kind of with the web in mind, with desktop applications going to the web, or later with web applications going further to the apps model. But yeah, it's still quite relevant to actual coding, because you've seen the observable and collections example, where the same thing were differently named, and that brought us confusion. And every confusion point is something we have to stop, think about a while, and say, oh yes, that should be the way it should. That should be the way we go. And each and every stop just makes us slower, and that's something we don't want. Error prevention. Even better than good error messages is careful design which prevent problem from occurring in the first place. Yeah, that's very obvious in our world, but that's something usually compiler handles. We don't have to work about it in our code. Now it's important one. Recognition rather than recall. Minimize the user's memory load by making objects, actions, and options visible. The user should not have to remember information from one part of the dialog to another. In our case, from one part of the system to another. Instructions for use the system should be visible or easily retrievable whenever appropriate. Oh yes, this is very important. And this is exactly what build a pattern is about. That we don't have to recall why this certain things are built in such a way, because we have an instant information how we should follow and what should be the next steps. Flexibility and efficiency of use. Oh yes, that's also accelerators unseen by the novice user may often speed up the interactions for the expert users such that the system can cater for both inexperienced and experienced users. Whenever we have a builder pattern, it actually somewhere under the hood uses the fully fledged multiple parameters method or constructor to actually build the object. We can use it straight away, or we can use the pattern, and whatever situation we are encountering. Aesthetics and minimalist design. Dialogues should not contain information which is irrelevant or rarely needed. Again, that's very important, and that's the optional parameters, all the nulls we have to put in functions, because we are not using this particular parameters. Final two, errors recovery. Help users recognize and diagnose and recover from errors. Yes, that's important, but not in the case of developers. And last but not least, help and documentation. Even though it's better if the system can be used without documentation, It may be necessary to provide help and documentation. Yeah, it's helpful, but it doesn't relate to coding per se, so not much that. So why are we talking about those heuristics? Heuristics are kind of easy evaluation methods. There should not be many of those, like a handful, 10. So that whenever we start to working with the code or we're looking at the code, we can run through those and say, yeah, that's fine, that's fine, that's fine, that's fine. Okay, I'll have to think about this particular problem because... So kind of a checklist that will help us walk through existing code or a new code, whether it's built in such a way that that we can live with it. Heuristics are to spot the problems and just quickly and efficiently and then do something with it. That's not kind of a rule of thumb how things should be designed. But this leads me or us to yet another takeaway. There is something like usability of code, because bad code is a usability problem, at least in my opinion. Or it's whether bad code or bad design or bad architecture whatsoever. It's a usability problem, and it should be treated like that. In our industry, in most of the cases, when we as engineers encounter a usability problem in the traditional sense, what we do, we don't change the usability of the system. We add some more sections to the manual. Because, you know, users are doing it wrongly. No, it's a usability problem. And usability problems come with the cost. And there's something like cost of the usability problem, and that's something user experience guys are always talking about. Because if there are usability issues, people are unable to complete common tasks, they are significantly slowed down, or they encourage frustration and irritation. So if any of you are still working, for example, in Spring version 2 and are working configuration in XML files, which still happens, that's exactly the problem we are facing. It's not about, you know, badly written system. It's about usability issues that this system imposes, and we haven't migrated it, or we haven't changed it further. So are there any heuristics for software? Are there any usability heuristics for software? Of course there are. There are quite a lot of those. And in the last chapter of the clean code book, there were 27 heuristics for the clean code, or kind of a clean code checklist. It covered comments, environment, functions, general programming ideas. There were a few special for Java. We had about naming and testing. There are quite a lot of those. We can read them through, but yeah, that's quite a lot of it. But still, 47 heuristics, how to write better code. Where does it all go? Why do we have those heuristics, and why think about it? Because, as I hope I've shown you, there are some cognitive limitations on our brain and how we perceive things in a certain limited way. And whenever we approach a code, we have to walk through it as any other physical or virtual objects. We have to understand it. We have to figure out what it does. We have to figure out how to change it, and we have actually to change it. And all these steps, the harder they are, the slower we are in our programming. So whenever we code upfront in a way that it adheres to those limitations, that makes us a more efficient programmer, and that makes everybody around us more efficient, which pretty much is the idea altogether. When it comes to psychology, there are many things we can talk about. There are affordances, which I've shown you. There is a concept of short-term memory, and there is the fully fledged memory model, how the memory is operating and how it's stored. There are some heuristics coming from UX which we can or cannot apply to the programming, but there is more things I haven't covered. There is the concept of complexity, and complexity which we accidentally add to our solutions, which is not inherent because we are doing insurance, it is hard. It's kind of accidentally added to the solution of the problem. We have the things called attention span, and there is a whole psychology set of papers about that attention span and how people are putting attention to certain things. There's a concept called flow, that if we get immersed into a certain activity, we are very hard to be to be distracted, but we have to get easily there and stay there. It's also described in the psychology. There are a lot of them, and some of them are already discussed in a book called The Design of Everyday Things. This is coming from Donald Norman. He was one of the was he? Yeah, he was one of the Apple guys, kind of a very first designer in Apple, and he wrote a very good book about how to design physical objects. I really recommend it looking into that because it gives you a totally different perspective onto how people perceive physical things. So if I have to leave you with something, I would like to leave you with 2 rules of thumbs that might be helpful to state your own heuristics for programming and for the way you design your code. The first one will be don't make me think. And it's again coming from UX, from Steve Krug. It was written, who said that the web page should not make me think. I shouldn't have to figure out what this web page is about to understand it. And the same in a programming. I don't want other people to think, how to use this particular API. That should be as easy as possible, because there's a lot of things they have to remember and understand from their business domain. Then they are writing a certain piece of code about insurance, about car industry, about autonomous vehicles, whatever. There is a lot to understand and to remember. I do want them to get through my API as quickly and as smoothly as possible, with with as little upfront investment for understanding the API as possible. And the second one, a bit of empathy never killed anybody. And that's something coming from Ken's Beck implementation patterns. He said this whole book is about empathy, about thinking how others are perceiving the code I've just written, how others are working with it, how I can satisfy with this code other humans' needs, because there are humans on the other side of the code I am just writing. So the smaller cost of understanding upfront, the smaller cost of the solution as the whole. So the 2 rules of thumb that I always start, evaluating my code with, and that's something I hope you will remember. That's from me. Any questions? If there are no questions, thank you very much. There are links and the slides over the internet, the whole source of the presentation and all the links I was referring to and all the books are available online. So if you find it somehow interesting, you can go there and figure it out. I'll be staying there until the end of the conference, so I'm happy to talk with you and discuss whether it's helpful or not. Thank you very much. And enjoy the lunch.